All right, so we're back and ready to jump into another one of those AI deep dives you guys seem to love.
I know I love them.
Yeah, you know me, I always get super excited about this stuff. So this time, you guys, our awesome listeners, sent us this research paper, like hot off the press, straight out of Google DeepMind.
Oh, wow.
Yeah, right? Motion prompting. Controlling video generation with motion trajectories.
Digi.
It's a mouthful, right? But basically what we're talking about here is not just AI making videos, but AI kind of being like, I don't know, like a movie director or something.
They're controlling how the videos are made.
Yeah, exactly. Like you're the one calling the shots,
Yeah, interesting.
So, I mean, we've all seen what AI can do with pictures. Right? Like those text prompts, it's amazing. But video, I mean, that's a whole other beast, right?
Yeah, absolutely. Like, how do you even describe motion with words? It's like so limiting.
Right. Text prompts are kind of clunky for that. But this motion prompting thing, it seems like it could be a way more intuitive way to like get what's in your head onto the screen.
Yeah, instead of trying to like force our ideas about movement into words, we can just use motion itself.
Whoa, okay, so we're not talking about words at all. Like, how does that even work?
Well, imagine you're like tracking the movement of specific points in a video.
Like dots moving around.
Exactly, like dots, yeah. And these point trajectories, that's what they call them, they basically form a kind of blueprint.
For the AI to follow.
Mm-hmm. And it can be, a few points, or it could be thousands. Depends on how much control you want.
Oh, wow. Okay.
Yeah.
So is it like giving the AI a stick figure animation and it just fills in the rest?
Kind of, yeah. You're on the right track.
I'm trying to wrap my head around all this.
So to get technical for a second, what the researchers did was they took an existing video diffusion model.
What's it called?
It's called Lumiere. And they basically upgraded it, you could say, with this technique called ControlNet.
ControlNet.
It's like an add-on that teaches the AI to like understand and interpret these motion prompts.
So they're not starting from scratch. They're just like giving the AI an upgrade.
Exactly. Makes things a lot easier.
Well, that makes sense, but I bet it still takes a ton of data to train an AI to do something this complex.
Oh, you have no idea.
What did they feed this thing?
So get this. Over 2 million videos.
Whoa.
But here's the real kicker. They didn't just track a few points. They did what they call dense tracking.
Okay.
Which means they captured the movement of thousands of points per video.
Thousands. Geez, that's a lot of data.
That's Google for you.
Yeah, that makes sense.
But all that data, it means the AI has this incredible ability to, understand and generate really complex motion.
Wow. Okay, so I'm already geeking out over here, but let's get to the part everyone's really waiting for, right? Like, what can you actually do with this motion prompting magic?
Okay, so one of the things that really blew my mind was this interface where you can directly interact with images.
What do you mean?
So imagine this. You can literally drag a part of an image with your mouse.
Yeah.
And the AI generates a video based on that movement.
Wait a minute. So you're saying, like, I could take a picture, drag a lock of hair, and the AI would make it, like, blow in the wind?
Exactly.
Whoa, okay. That's trippy.
And what's even cooler is that it's not just simple movements.
No.
The AI seems to understand some basic physics. Like, if you drag sand, it'll realistically shift and settle.
No way.
Yeah, they even showed how you can control object rotation.
Really?
Like in one example, they rotated a cat's head using motion prompts.
So you're not just animating static images, you're like bringing them to life with this crazy level of control.
That's what's so exciting about it. And we're just scratching the surface here. Like, imagine what this could do for movies, for animation, even for VR.
Whoa, okay. Now my head is really spinning. But before we get too carried away, dreaming about the future, let's come back down to earth for a second.
Okay.
What about the limitations? It can't be all perfect, right?
You're right. It's not all sunshine and roses.
So what are we talking about here? What kinds of limitations?
Well, for example, sometimes the AI makes choices that, don't really make sense.
Okay.
Like, instead of moving an object that's already there, it might create a whole new one.
That's weird. Why would it do that?
It's like the AI's internal logic isn't always aligned with how we, see the real world.
So it's like it's thinking differently.
Yeah, it's almost like by seeing where it stumbles, we can learn more about how it's actually thinking.
Like getting a peek behind the curtain of its AI brain.
Exactly. These limitations, they're not just problems to be solved. They're opportunities to, probe the boundaries of what these AI models can do.
I like that.
And really understand how they work.
Corrective failure, right.
Exactly.
So you mentioned earlier some other applications like controlling the camera and transferring motion.
Okay.
Those sound super cool. Tell me more about those.
All right, so imagine.
All right, so camera control and motion transfer. Those are the other two big applications you mentioned.
Yeah. Those are the ones.
And you were saying they're like game changer.
Oh, absolutely.
Yeah.
I mean, think about it. Camera control basically lets you be a virtual filmmaker inside the AI's world.
Whoa, okay, so instead of just controlling like what's happening in the scene, I can control how it's being shown.
Exactly. You're guiding the camera with motion prompts, deciding what the viewer sees and how they see it.
That's pretty wild. Like I could create a sweeping shot of a landscape or zoom in on a character's face at just the right moment.
You got it. All those cinematic techniques right at your fingertips.
Okay, so that's camera control. But what about motion transfer? That one sounded even crazier.
All right, so motion transfer is where things get really interesting. It's basically taking the motion from one video and like slapping it onto a totally different image.
Wait, so you're saying I could take a video of someone breakdancing and make it look like a building is doing the moves?
Well, in theory, yeah. Although it works best when the source and target images are kind of similar. But yeah, that's the basic idea.
My mind is blown. So what kind of examples did they show in the paper?
One example they gave was transferring the motion of a human turning their head onto a monkey.
A monkey? I could see that getting kind of creepy, you know?
Yeah, there's definitely potential for some uncanny valley stuff there, but actually it looks surprisingly realistic. Yeah. They even did something even weirder. They took the motion of a monkey chewing and applied it to a picture of trees.
Chewing trees. Okay, now I gotta see this. What did that even look like?
It's really strange. Like the trees are kind of undulating and warping as if they're chewing, but only when the video's playing. If you pause it, they just look like normal trees.
Whoa, okay. That is wild. It really shows how much our perception of something can change when you add motion. You know, it's like it tricks your brain into seeing something that's not really there.
Totally. It plays with your expectations. And speaking of expectations, all this talk about motion transfer and these crazy examples reminds me of those moments when the AI kind of messes up, you know, like it does something totally unexpected.
Right, like when it creates a new chess piece instead of just moving the one that's already there.
Exactly. That one really threw me for a loop. It seems so illogical.
Yeah, why would it do that?
Well, it suggests that maybe the AI is prioritizing the concept of the object, like the idea of a chess piece, over its actual physical presence in the scene, as if it's trying to follow the rules of the game, even if it breaks the rules of reality to do it.
So it's like it's not just mimicking what it sees. It's actually trying to understand the underlying rules and apply them in its own way.
Yeah, and sometimes that leads to these really interesting results that, you know, challenge our assumptions about what AI knows and how it learns.
It's like it's showing us a different way of thinking.
Exactly. And motion prompting gives us this awesome tool to explore those different ways of thinking.
Oh, so?
Well, remember how we talked about the different levels of density in the motion prompts?
Yeah, like how much detail they give the AI about the movement.
Right. So researchers are using that density variation to test the AI's limits, basically. Like, how much information does it need to understand and generate complex motion?
It's like giving the AI a vision test, but for motion instead of letters.
Haha, exactly. And what they're finding is that even with very sparse prompts, like just a few key points of motion, the AI can still create these really nuanced and realistic movements.
So even with just a little bit of guidance, it can still draw on all that knowledge it has and produce something amazing.
Exactly. And that's what's so cool about these AI models. They're not just blindly following instructions. They're interpreting, extrapolating, and even like expressing themselves in these unexpected ways.
It's almost like they're becoming artists in their own right.
That's a great way to put it. It really blurs the line between tool and creator, you know?
Definitely. And with motion prompting, it feels like we're just at the beginning of exploring all that potential.
Oh yeah, we're just scratching the surface here.
This is definitely one of those deep dives where I walk away feeling like I've learned a ton, but also with way more questions than answers.
Isn't that the best kind of learning, though?
Totally.
Yeah.
So where do we go from here? What other mysteries does this research have in store for us?
Well, in our final segment, we're going to dive even deeper into how motion prompting is being used, not just to create cool visuals, but to really push the boundaries of AI itself. We'll be looking at how this tech helps us understand what these models truly know and how they learn in ways that continue to challenge our understanding of intelligence itself.
Okay, I'm ready for it. Bring on the grand finale. Okay, so we're back for the final part of this deep dive into motion prompting. And I got to say, this has been one wild ride.
Yeah, it's been pretty mind-blowing.
It really has. Like,
Yeah.
I feel like we've explored this tech from all angles, the applications, the implications, even those moments when the AI does something totally unexpected.
Right, the limitations.
And it's those limitations, those like glitches in the matrix that I find so fascinating.
Yeah, I know what you mean. It's like they give us this glimpse into how the AI is actually thinking.
Exactly. Like we can learn more from its mistakes than from its successes.
Totally. Think about it like this. When a kid's learning something new, it's their mistakes that really show us how their brain is working. Same with AI. By looking at those weird moments where it goes off script, we can start to understand its internal logic.
It's those aha moments in psychology experiments,
Right.
when you get an unexpected result and it suddenly unlocks a whole new understanding of how the human mind works.
Exactly. And motion prompting gives us this awesome tool to create those aha moments in AI research.
Oh, yeah, that's right. We were talking about those variations of motion prompt density, right?
Yep. Researchers are using those variations to basically stress test the AI. Like, how much detail does it need to make sense of movement? How much can we push it before it breaks?
So they're feeding it these motion prompts that range from super simple to incredibly complex.
Exactly. It's like a vision test, but for motion instead of letters. And what they're finding is that even with just a few key points of motion, like a really sparse prompt, the AI can still generate these amazingly realistic and nuanced movements.
So even with limited info, it can still tap into all that knowledge it's learned
Yeah,
and create something amazing.
exactly. Which is what makes these AI models so fascinating. They're not just robots blindly following commands. They're interpreting, extrapolating, even improvising in a way.
It's almost like they're becoming artists.
I like that. It really blurs the line between tool and creator, doesn't it?
It does. And with motion prompting, it feels like we're just starting to explore all the possibilities.
Oh, absolutely. We're just at the tip of the iceberg here.
And I gotta say, I'm walking away from this deep dive with way more questions than answers.
Uh-huh. Isn't that the best kind of learning experience, though?
Totally. It makes you want to keep digging deeper. So before we wrap up, any final thoughts on this whole motion prompting thing?
Well, I think the biggest takeaway for me is that we're witnessing the birth of a new kind of intelligence.
Whoa. Okay. Tell me more about that.
It's not just about AI mimicking humans anymore. It's about AI developing its own unique ways of understanding and interacting with the world.
Like its own way of thinking.
Exactly. And motion prompting gives us a window into that thinking process. It lets us see how AI perceives motion, how it learns from its mistakes, and how it pushes the boundaries of what we thought was possible.
You're right. It's a humbling reminder that we humans don't have a monopoly on intelligence.
Exactly. And the more we explore these new forms of intelligence, the more we learn about ourselves and the world around us.
Well said. This has been an amazing deep dive. Thank you so much for sharing your insights with us.
It's been a pleasure. Always happy to talk about this stuff.
And to all our listeners out there, thank you for joining us on this incredible journey into the world of motion prompting. We'll be back soon to explore another corner of the AI universe. Until then, keep those minds curious and those imaginations running wild.